ନମସ୍କାର, ଜୟ ଜଗନ୍ନାଥ। ମୁଁ ସମ୍ବିତ ଭୁବନେଶ୍ୱରରୁ। ସୋ ଓଡ଼ିଆ ଇନ୍ ଏମ୍ଏଲ୍ କନଫରେନ୍ସର ସମସ୍ତ କର୍ମକର୍ତ୍ତା ଏବଂ ଆୟୋଜକମାନଙ୍କୁ ମୋର ହୃଦୟରୁ ଧନ୍ୟବାଦ। And this is a great opportunity for all of us, all Odias across the globe, to showcase our works, to understand how the world is changing rapidly through machine learning and artificial intelligence, and how the data, which is the new fuel of, of this century, and how it is shaping the world in a better way. So, prior going to what I intend to speak about my ideas on machine learning, let me give you a few brief about myself. I work as an assistant professor with School of Electronics Engineering, KIIT University, Bhubaneswar, and I specialized in a field of signal processing, machine learning, Internet of Things. My current research is focused on biomedical healthcare, and making the world a better place. So, in nutshell, I work with companies. I work with the academia. I consult startups in their product growth and everything. And in short, I work with students very keenly in my university uh, to make the world more resilient to the technologies, to make the world a better place to live with, and make the world more greener for the future generation. So uh, there is a lab in my department which I handle. It's called Design and Thinking Lab, where we try to ideate, innovate. Uh, from we create technologies, we license technologies from there, and so that it will be beneficiary to the community in and around Odisha. Okay, so let me share my screen. Uh, let me share my screen. Yes. Yeah. Okay. Now, so as you can see, yeah, it's taking a little more time to load, but yeah. So once again, so let me introduce myself. I am Professor Sambit Prasad Kar from KIIT University. I'm an assistant professor with School of Electronics Engineering, and I also liaison a lab called Design and Thinking Lab, whose sole motto is to ideate, innovate, and inspire the next generation. So today we are going to today I'm going to showcase one of the product which we developed along with my undergrad students in the lab, and mostly I thank to my undergrad student Prakhar and Subham, Akshat, and everyone who was very keenly associated with this project for developing, and which is already a running solution with a leading steel company in Odisha. Okay, that product is industrial data control and monitoring node for predictive maintenance. It's an industrial IoT and machine learning based solution for large scale industries such as steel, aluminum, and everything. So this is right now operated with the Bhusan Steel plants, Jharsuguda, and we are planning to elaborate or extend our ideas to larger arena. So what is this? So let me walk through you the flow of the presentation. That is, let's start with the introduction. What is that? What is predictive maintenance? So what is the industrial IoT solution? What is the machine learning part in here? Then what is the solution we proposed? How we implemented? And what is the future scope? And then we can conclude the meeting. Okay. So it's just a very large paragraph, but in not cell, if we can say that everyone is aware, the industry uh, in past 2 to 3 years has been technology and data driven, and which we call as industry 4.0. And all the corporates, large industries are investing heavily on data analytics, so that they can improve the efficiency, they can improve the productivity, they can reduce the cost, and even they can make their presence more valuable in the market. One of the main advantage is uh, in failure prediction and root cause analysis, and thus it is making us possible to reduce the resources in such time dedicated to reactive repairs. So while reducing failure events on critical components or equipment, still real-time remote monitoring of the manufacturing industry has not been implemented in very dedicated manner or a true sense. And also lack of predictive maintenance in Indian scenario, moreover in Odisha, everything is still it's still a daydream, you can say. So my our idea is to implement a system of sensors and nodes with predictive maintenance, a machine learning algorithm running in the backend, which acquire the data, analyze the data, fit a model on top of it, and predict that when your equipment is going to fail, so that you can carry on the maintenance. So that is the main purpose of predictive maintenance. So what we do, for this purpose, we acquire and analyze large real-time data from thousands of devices in the operating or in or running at the customer premises over a wide range of product lines and scenarios. So let give you a 1 minute quick look what is predictive maintenance. Predictive maintenance, so let's what is maintenance. So when we have gone for we have an industry and we have some machines running in our premises, so it these machines are going to be wear and tear after certain runs. So what you do, we propose maintain or we use apply certain mechanism to maintain the machines. So there is three different mechanism, which is very widely the first two mechanism, which is called reactive maintenance, that a machine breaks down, you call the mechanic, you call the engineer, and uh, try to repair it or try to replace the broken clog, broken piece, and up and run, make your machine up and running. And this is again, this is not a very small procedure. It will take some time, and thus it makes it difficult to create a reactive maintenance all the time. Since comes preventive maintenance, second part is preventive maintenance. So you will carry on a schedule check on maintenance, that okay, this is my maintenance period, I will keep on carrying it. So suppose 10 days is my scheduled checkup, I will do a 10-day checkup in each 10-day interval. Again, this is a redundant job. Okay, so there comes the third one, which is predictive maintenance, that I must have a forecasting mechanism which can forecast based on my critical parameters in my machine, that okay, you can go on carry on your work till this date, and or you can carry on your work till the machine going to be get failure in certain days with a plus minus error. So right, so we depend on predictive maintenance helps you estimate when your system is going to fail. This way you can schedule repair in advance, properly control your inventory, minimized unplanned downtime. So downtime is a very critical measure in large industries, so we can minimize the unplanned downtime and extend the lifespan of your hardware or equipment. Right, so basically what happened, predictive maintenance helps you to predict the time of the system to malfunction. So once you know that my system is going to go through a fault after certain days, so it is wise, you can optimize your time, or you can use the time where your productivity is low for maintenance purpose, so that your loss of manufacturing is less. So predictive maintenance not only detects a possible loss but also recognizes faults with the complicated machineries and lets you work with elements need to be replaced. So you can see that if you look forward to this graph, this is mission health with respect to time. Now I am over here. So if my preventive maintenance is scheduled over here, that at, at every point I'm going to carry out in same interval, but what my predicted failure is here. Suppose this is 10 days and this is 20 days, so somewhere around 18 days I have a weekend where my productivity is low, I can schedule a maintenance at that time, right? So that I can maximize my productivity and minimize my downtime. So how to incorporate predictive maintenance in the existing system? That's our one of the largest problem, because if you go to the companies and they are not ready to change their system at a go, so what we have to do, we need to create algorithm, we need to acquire the data from the machineries, we have to create a predictive maintenance algorithm, right, using machine learning, and which will going to predict my system fault in. So suppose my this is a lathe machine, it has some critical four critical parameter data which is going through my algorithm, and it has predicted that my system is going to be fault into 30 plus or minus 2 days. That means either 28 days or in 32 days. So what I can do, that I can schedule a maintenance anywhere between 25 to 28 days, right, so that my machine does not go out of business. So in nutshell, what is the workflow? Whatever workflow you want to implement is that algorithm creation begins that the data which is going to acquire from the machines using different sensors modules with that explains the method in a number of safe and deficient conditions. So those parameters, the data will tell us that which condition is safe and which condition is deficient or maleficent. Then the raw data is pre-processed, or which in machine learning terms is known as the data is cleaned, and it take a shape from which you can derive the state markers or indicators that the machine is going to be get faulted or going to get faulty in within some days, right? So there are characteristics that help to differentiate between a good and a deficient or a maleficent condition, where you can use that extracted feature to train a machine to learn, or to create a system to learn these three major things, that is to detect anomalies. So what are the anomalies can occur, right, based on my state markers, or classify different type of faults. So if I am going for a conveyor belt, which is one of the major implementation in our system, that how many, when the conveyor belt can stop, what are the braking mechanism, right? So classify different types of faults. And third, it will going to estimate the remaining useful life, which is called rule of the machine, that how many years or how many months or days you can use this machine without a maintenance. Okay, so these are the three basic models which we have implemented in our system, right? So which is basically the predictive maintenance, what is called the predictive maintenance bible. But what are the main things we have faced, I'm going to explain in next. Finally, you deploy the algorithm and integrate into your system for machine monitoring and maintenance, which is very important. I design an algorithm, now I have to put into, yeah, or deploy it this in and integrate along with my existing machines, right? So our proposed solution, our solution is involves that we take the distributor control system of the manufacturing unit, we take acquire the data. So this can be a PLL data, or this can be a data from another vendor, we don't care about that. We take the control data from those manufacturing stations through this distributor control stations. The connections can be established via internal network or accurate architecture spread across distinct locations. The proposed system receives the signal from the manufacturing station using the industrial Modbus TCP protocol. This data is comprises of several critical alarms and analog signals of the manufacturing unit, right? That's our problem. So this is, if you go to this box, so this is the distributor control system, which is from where I'm going to implement my where I'm going to acquire my data, right? So there is an intermediate gateway, this can be a switch or this can be a hub, then this is my network distribution area. And so these are all the internal architecture of the company or the industry. So here our solution, this is the black box. So this is where, this is basically a data acquisition card. So this is going to acquire the data from here. This is a proposed system, so I cannot explain more because this is a patent still pending on this system. So this is the proposed system. So this is going to acquire the data, encrypt the data. Again, this encryption is another our invention. So this encryption methodology which makes the system more reliable. Again, there is two patent pending on this. One is my on this black box, the architecture itself, another one in the communication protocol. Then the data is acquired and stored in a database. So here there is an application running on top of, from the storage devices, there is a mobile application which runs on top of it. And this application has different layer of securities. So if a manager wants to see, he can see a lot of more different kind of machine parameters compared to engineer can see more different kind parameter than an operator, right? So it can visualize the data on and off from a remote location through a mobile application, through a through mobile application, and through websites and all. So this is basically our solution. The DCS connection is once established, the data encryption happens. So this is a blockchain enabled data encryption system, whatever implemented over here. Then the data is sent to the storage unit and the data is pre-processed. Once the data is pre-processed, there is two ways. One, first, that the data handling of end user application. The user can visualize the data, user can use see the data, user can trigger the alarms and everything. Second, on this base of the data, we are going to implement our machine learning or AI algorithm to create our predictive maintenance profile. So once the data is received, it is encrypted, sent to cloud server using the standard protocol. The protocol which is used from DCS to the cloud servers or the network server is standard. We are not going to change this. The server simultaneously communicate with an application layer, that is a mobile application. The application layer contains an interactive display for all the transmitted data. Moreover, it includes privilege-based authentication, that the authentication label or the number of parameters of privileged person can see is different from a non-privileged person. That an engineer can see more parameters compared to a operator, and like that we have designed as per the company requirement. Then the application layer is integrated with multiple features such as live notification for critical alarms, timestamping of critical alarms, trend reports of analog parameters. In addition to that, this integration of local community, so this can also act as a local community transmission based mobile application where two operators can discuss among these things that my parameter is going like that. What is your opinion on that? This will create a crucial role in managing the workforce. This solution has been implemented as a solution to the steel industry at Bhusan Steel, Jharsuguda, where our system collects the data and make the data clean so that the model can be implemented to perform predictive maintenance on critical parameters. The user-friendly mobile application and the critical parameter alert system is quite helpful in managing the machinery efficiently, and this is running for quite some times in the industry premises. So you can see a simple interactive way, so you can see how this UI runs. So these are the parameters which we are telling: the process alarms, the mechanical alarms, the analog readings. So you click on analog readings. So there is 4 parameter: electrical, process, mechanical, and analog readings. You then click on that. So this is one of the analog parameter, which we can see visualized directly from anywhere in the world based on your privilege. So what is the future scope? The future scope is very prominent for our solution because till now the large industries which are works on tight margins and tighter time frames, so on-schedule time downs is a nightmare. So the predictive maintenance has to come to picture. So if you see the large conglomerates like GE and BMW, they have started implemented. So, and with our solution, which is much cheaper to the existing localized existing solutions, can prove to be a game changer to the local industries. And this can also enable us to make corrective maintenance before an issue surfaces. The data collector from the proposed system can be utilized for collecting various critical data, and same data can also be used for predictive maintenance based on machine learning algorithms. And this can have a huge impact in the industrial maintenance, especially to the small scale industries which is in and around Bhubaneswar, which they can use for very small amount of charge, and very less compared to the existing solution, which is driven is quite which is quite costly for the medium MSME sector. Okay, so on a lighter note, I need to conclude that the proposed system, this is the industrial internet of things and machine learning based system, which has a huge impact for better monitoring, control, and maintenance of the industry. And this system provide access to live feeds of the manufacturing station at every location our system. So analyze the critical parameter, perform the predictive maintenance, alert the managers in case of a sudden damage also, so that this can help abort the large scale disasters. And also the analyzed data help the industry, as per the industry feedback, the existing system help them a lot to maximize their machine lifespan, and thus it is proving to a boon to the medium small scale industries. Thank you. Jai Jagannath. So I hope this machine learning conclaves have a huge impact on the ODI conglomerate, ODI diaspora across the globe. And thank you for listening to me. Namaskar. Thank you. Namaskar.